Hey guys, welcome back to the channel. Until the previous video, we have looked at the theory part of the Arduino, like the basics of Arduino board, how to work with the IDE, and also some basic parts. From this video onwards, we'll jump into practicals by doing different projects. Today, let's start with the most basic and easiest project, the classic LED blink. So what is an LED? LED stands for light emitting diode, which is, as the name suggests, a diode. This means current can only pass in one direction. It has two terminals, the positive anode and the negative cathode. The longer terminal is the positive terminal and the shorter one is the negative terminal. Anyways, now let's look at the hardware connection. Firstly, we'll be using an Arduino, a breadboard, a light that is an LED, and a resistor. We also use some jumper wires for connecting the different components. We will use a breadboard for these connections as it makes it easy to understand and follow what's happening and eliminates the need for any soldering. So firstly, we'll connect the positive row of the breadboard to the VCC of the Arduino Uno. So the positive row is the power rail for positive. It runs all along the breadboard. Next, we'll connect the negative row to the ground of the Arduino board. Now we can use power from the board for our components. We'll give the power to the LED by connecting the ground to the cathode. So firstly, after placing the LED into two different rows, the two terminals should be in two different rows of the breadboard. We connected the negative of the LED to the negative of the breadboard using a resistor. It is important to use a resistor here to limit the current flowing through the LED, as excess current can damage it. An LED is a digital device, so we have to connect it to any of the digital pins. Let's take pin 9 and connect it with the positive anode of the LED. We don't need to give a positive power supply to the LED because the digital pin will act as the positive. Now coming to the coding part, we'll open the IDE and connect the Arduino Uno to the computer. We'll select the board and COM. We'll connect the board by selecting the Arduino Uno option. If you don't get the Arduino Uno option, then you can go to Tools and go to Board and the Arduino AVR boards and select Arduino Uno from there or any other board that you're using. And then next at port, we connect to the COM5. Or in different computers, it varies. Select the one with Arduino Uno in the parenthesis. Now coming to the coding part. Firstly, let's declare which pin we have connected to the LED. As we are using pin 9, we'll name a variable that is LED with an integer data type and assign it to the pin number. For this, we write int LED is equal to 9 and then we have to add a semicolon because to end each line it's important to add the semicolon. Now inside the setup, we have to tell the Arduino that the LED on pin number 9 is an output device. For this, we have to use a pin mode function. So what we do is we write pin mode with M capital, and inside the brackets we have to write the pin number and then whether it's input or output. Here, because we declared LED as pin number 9, I'll write LED and then output. And a semicolon to end the statement. Now we have to make the LED blink on and off continuously. For this, we use the loop. Firstly, we have to make the LED turn on. So we do this by supplying power to the LED. For analog devices, the current might vary, but for an LED, it is only 5 volts or 0 volts because LED is a digital device. So we have either on or off, which in Arduino terms is high and low. Because we are sending instructions to the LED, we use the digital write function. What we have to do is write digital write with W capital and then the pin number, and then if we want to make it high or low, here we write digital write LED high and end the statement. Next, we have to keep it on for some time. So we use the delay function. I'll use around 500 milliseconds or half a second. Now we have to turn the LED off again. So we do this by using the same function, but this time making it low. So we write digital write LED low. And again we use the delay to keep it off for some time, and say again 500 milliseconds. Now we have done the sketch. We have to compile it and then upload it. By clicking on the tick button, we compile the code. Once it's compiled, we now upload it. It's worth noting that while uploading, the IDE automatically first compiles the sketch and then uploads it. So technically, you don't need to compile the code manually after all. But I would still suggest you to do so, and I'll do so myself. Now you can see the LED blinking every 1 second. So the code is working. Now we'll do something else. We'll change the delay to 1 second, that is 1000 milliseconds. And upload it. Now the LED is blinking slower compared to the previous LED. Similarly, we'll try something else, but this time we'll make the delay to about 100 milliseconds. Now we'll compile and upload. It says done uploading. So as you can see, the LED is blinking much more faster. Anyways, to summarize the entire circuit, so firstly what we did is we supplied power to the breadboard using the VCC from the Arduino, and then we also supplied the negative to the breadboard using the ground from Arduino. Then from the LED anode, that is the positive terminal, we connected pin number 9, that is a digital pin. So after that we used a resistor to connect the LED's negative terminal to the negative of the breadboard. So what this does is the power from the Arduino digital pin 9 will flow to the LED's positive, and the code that we used will be executed, and then the power will exit the LED from the negative. Anyways, that's it for this small project. It's just a small step, and we'll do much more projects together soon. Until then, goodbye.